Hello, thanks for visiting Python Foundations. My name is Wesley Beckner. I'm a data science instructor at the University of Washington's Global Innovation Exchange. Before we dive into today, I want to share with you how to navigate the course documents. So there's two ways to uh, digest and take the contents in this course. Option one, you'll see on the main website page, there's a link here, visit the GitHub repo. If you visit the GitHub repository, you'll end up here. And what you'll want to do is hit this button, fork, and fork this repository into your own GitHub. Now, all of the repository documents will be owned by you. And so if you run these notebooks locally, all of your notes and work will be saved. Second option is to visit, as I'm doing here, the session or lab or project link for the day. And then in each of these is a button at the top that says Open in Colab. If you visit that button, it will open up the notebook in Colab, and you can just run the notebook in the cloud. Again, to save your work, you'll want to hit this button, copy to drive, and then all of the code that you write and run for the day will be in your Google Drive. So two ways to navigate this course, either the GitHub repo or through Google Colab. It is up to you what you would like to do. And now we will dive into the topic for today. In this session, we will cover computer coding in Python, as well as navigating the Jupyter Notebook environment, which is what we are reading from at this moment. A lot of us are familiar with Excel, and when we get started in Python, it may seem like a lot of what we are doing could be easily done in Excel. So why would we want to make the transition? There are four different ways to look at this that I like to introduce to newcomers to Python. That is through simplicity, automation, scalability, and connectivity. Now, Python takes the cake for automation, scalability, and connectivity, but the simplicity of Excel is hard to beat. So let's talk about that first. So in terms of simplicity, Excel runs through a GUI, that is a graphical user interface, and it makes simple calculations, well, simple, right? We're all very used to clicking into a cell, hitting the equal sign, and writing some type of calculation. To make matters even better for Excel is most people have at least a rudimentary proficiency in Excel, so it makes sharing documents really simple. On the Python side, it is a steeper learning curve. This is unavoidable, but to our advantage, our learning material for this course is curated so that we learn Python while solving relevant problems. Lucky us, you do not need to set up your own coding environment. And this dovetails back into the first thing I talked about, which is the two ways to digest this course material. So thank you, Google Colab, for your cloud environment. Moving on, automation and data connectivity. On the Excel side, we need to execute XLSX files with the relevant data. And so this forces us into a copy, paste, and edit paradigm, right? If we're wanting to run the same analysis on a new set of data, we will often have to copy and paste that data into a new Excel worksheet, or perhaps copy computational cells from another notebook. And this can get really hairy. Python, in contrast, can integrate directly with databases. And so this makes updating the outputs of your Python program relatively simple. On to scalability and big data. Excel can handle less than millions of data points. Once you get over 1 million data points, Excel becomes a little slow. It also has poor version control. I can speak to many times where I've had to run an older version of a Windows operating system because I needed to access someone's older Excel document. In contrast, Python can handle millions of data points. And depending on what libraries you use to do that data analysis, it can potentially handle even more. We can integrate with querying languages like SQL. And we have version control and containerized environments like these notebooks that we're using. So our extraction, wrangling, and analytics can all happen in one place. Side note, the scripting language of Excel is Visual Basic, or VBA. This won first place. Hold your horses, see what it won first place for. 80% of developers who use this language stated that is the most dreaded language to learn. And this was in Stack Overflow's 2020 developer survey. So you want to avoid VBA if you can. That being said, okay, so with these things we've talked about, we won't only approach Python from a let's replace Excel standpoint. We will also be approaching it from a coding standpoint. That is, we write computer code to perform a set of tasks and instructions that the computer can help us accomplish. The real challenge and process of coding from an engineering perspective is how to codify a problem and knowledge of what tools are available to solve it. So I and the teaching assistants that I've had in the past have worked hard on the material in this session and the many that follow to demystify the confusion along the way while focusing on giving learning experiences in the relevant engineering and business problem areas. Python versus other languages. Our goal is to not only give an introduction to Python, but also to demonstrate general coding concepts. For these next few sections, we'll be executing various lines of code right here in this interactive Google Colab notebook. If you're wondering how this is possible and how this all works, don't worry. We'll get to the intricacies of interactive notebooks later on in the session. You'll discover the many benefits of this general purpose programming language. In particular, the syntax for Python is understandable to read and easy to learn, compared to the syntax of other languages that require more of a background of underlying computer sciences, languages such as Java, C, and C++. In this course, you'll discover that Python is especially ideal for working with scientific data. Topics such as data manipulation and visualization will be covered later on in this course, all while continuing to utilize Python. And the first time you run a cell in the Google Colab, you'll get this pop-up, Google sign-in required. You must be logged in with a Google account to continue. So I'll go ahead and log in. All right, and once you've logged in, you should be free to execute the cells in this document. Once you're logged in, you'll also get this warning. This notebook was not authored by Google. Go ahead and click Run Anyway. All right, you'll see this little animation showing that the cell is thinking. What I've done here is I've just outputted the version of Python that we're running. So currently, the default Python version in Google Colab is Python 3, and specifically 3.7. If you compare this notebook to Python code that you see elsewhere, note that if that code that you're seeing elsewhere is in version 2, you will probably recognize syntactical differences. So something to keep in mind as you're looking at other code that you may find around the internet. Another thing that I like to include when I motivate Python to new students is another data point that we get from the Stack Overflow developer survey. Python is the most wanted language out of developers. So if we look here, 30% of respondents said that they wanted to learn Python. So high in demand computer language. A quick primer on Python's syntax. Python's simple, concise syntax allows for faster prototyping of code than other languages such as Java and C++. However, that does not mean that Python has faster runtime execution than the others. This may be evident to folks who have been programming in the past, but to newcomers, perhaps not. So that's something to just note. Printing output to the console is as simple as running Python's built-in print function. To execute a code cell, we'll talk more about this later, you can either click on the play button next to the cell or use the keyboard shortcut Control-Enter, or if you're on a Mac, Command-Enter. So I'm going to click into the cell and I'm going to press the play button. And right, we see this string print out to the output of the cell. Hello, GIX students. The other way I can execute the cell is by doing Control-Enter. I can also do Shift-Enter, and you'll notice that my selected cell jumps down to the next available cell. Variables can be created just by typing the name you'd like for the variable, followed by the equal sign, and the value you want to assign the variable to. In this case, we'll create a variable called sum_school and set it to the value of University of Washington. Right? So I've got this variable sum_school equals University of Washington. I'll do Shift-Enter. And once we've defined the variable, we may then use those variables elsewhere. For example, we can output the value set for some school by inputting the variable name into Python's print function. So here's the same print function we used earlier, but now instead of typing directly into the print function the string I want to print, I'm going to type in the variable name that stores that string. And we see that what is returned to the output of the cell is University of Washington. A key part of coding is understanding which functions you need to use for accomplishing a task, as well as knowing when to create one of your own, which you'll learn more about later in the course. For now, what you should know is that print from earlier is one example of calling and executing a function that's already available to us. Exercise 1, a very common print statement. If you're watching this and wanting to do the exercises on your own, you can just pause the video, but I will go ahead and complete the exercises in the video. Now that you've stepped through our quick primer on Python, for our first coding exercise, try printing hello world to the screen. Then run the code cell either from the play button or the keyboard shortcut method that we introduced earlier. You may have noticed me taking new coding blocks without touching my mouse. You can do this by pressing escape, then A, or escape, then B to create a new cell block where your cursor is currently selected. So just to demonstrate, I've hit the escape key here, and now I've tapped A. And see, that opens a new cell. I can hit escape again, press X, or rather Control MD, and that will delete the cell. I'll do escape again and hit the B button. And now that opens a cell below where my cursor was, and then again, Control MD to delete the cell. All right. So cell for exercise 1, we're going to print hello to the screen. So I'll do print. Notice I have my parentheses that I open and then my double quotes, and then I'll type hello world with an exclamation point. There we go. Hello world is printed to the screen. What are variables? To have values that our computer can store in memory, we use variables. How else can we store information for later analysis and later reference? That's where variables come in and is an essential part of programming. Here's a basic example of assigning a variable using the equal sign. Let's call this variable x and assign it an integer value. We'll get into integers in just a bit. Here I've chosen the integer value of 25, so x equals 25. Let's create another variable called city_name and assign it the word Seattle. All right, so that's what I'm doing in this cell. And when we need to use this value again, we retrieve that variable by referencing it to by the variable name we gave it when first assigned. The x variable we created earlier can now be used later and as many times as we'd like. Existing variables can also be modified. Let's change the value of x after printing its initial value. So here on line 1, I'm going to print x. I'm now going to reassign the value of x and then print x again. Well, notice that the print that's returned went from 25 to 150 as I changed the value of x. All right. A few more notes on storing data as variables. Variables are nothing but reserved memory locations to store values. This means that when you create a variable, you reserve some space in memory for that value. You can identify the location in memory using names. And here are some basic rules for assigning variable names. They must begin with a letter, that is A through Z, and they can be either capital or lowercase. Or it can begin with an underscore. Other characters can be letters, numbers, or underscores. Variables are case sensitive. They can be any reasonable length. There are some reserved words which you cannot use as a variable name because Python uses them for other things. An example of some of these are false, none, true, lambda, from, and global, but there are many others. If you want to have more than one word in the name, the convention is to use an underscore in the name. There was a time when something called camel case was also acceptable. This is no longer the case. So camel case, you will just capitalize subsequent words in a variable name. You will still see this, especially maybe in class variable names, but the standard now is to use an underscore. As far as variables go, that is. Classes, still actually okay, I think, to use camel case, but for now we're talking about variables. And we'll talk about classes in a later session. Variable types, for your reference. We have a few different data types that can be stored under a variable name. Within numbers, we have floating point numbers, integers, as well as complex numbers, which we won't really get into in this course. We also have strings. We have Booleans, so like true, false. We have lists and dicts, which we'll cover tomorrow. Dicts is short for dictionary. We also have the none type in Python, or a null value storage. In this section, we will also introduce a built-in Python function called type that will help us facilitate understanding how variables are stored within Python. Let's explore some common variable data types in Python. The first type to discuss is a string, which we've already seen before when we initialized city_name. Strings in Python are simply a collection of characters wrapped around quotes, and a string can represent any kind of information depending on how it's used, such as a person's name, a city name, like we just demonstrated, or a complete sentence. Here are some examples of string variables in Python. We can also use single or double quotes, and triple quotes open whole blocks of string content. So here in this cell, I've put 3 single quotes. And now anything that happens between those 3 single quotes and 3 closing single quotes will be a part of the string. And we can see the return printed to the output of the cell. We also have this, what's called a regex character, a \n, and that means we've started a new line. Here's an example of using single quotes to store a string, double quotes. Notice that in this example, we have to use double quotes because I'm using the single quote as an apostrophe in the sentence. And then here is the triple quote designation again, but this time with double quotes taking the place of the single quotes, right? And everything that appears between the 2 sets of triple quotes is part of the string. All right, and here I'm using the type function to assess what kind of variable is being passed into the type function. And notice the output to here is str, that is short for string. Moving on, the other variable types we'll discuss for now are integers and floats. Consider the integer type as data that can represent any positive whole number or negative whole number. Recall the x variable we assigned to 25 and then 150 earlier. That variable would be considered an integer in Python. Here are some other quick examples of Python integer variables. Here I've got some integer stored as 5, number of breakfast for hobbits equal to 2, as many of us will know. We can also pass those variables into the type function. So here I'm passing the number of breakfast for hobbits into the type function, and the return is int, short for integer. All right. A float in Python is considered any number with decimal point values. This is the main difference between a float and an integer. For floats, some examples below show an arbitrary number of decimal places after the decimal point, and ones where a value less than 1, such as 1 representing a percentage value, don't require specifying a 0 left of the decimal point. So to take this concretely, here I've got the variable y, setting it to 21.0, half, setting it to 0.5, data generated by the Death Star, 2.08 exabytes per year. And here's my Star Wars source in case you're interested. So let's try something. If I pass 21.0 into the type function, I will see that it's stored as a float. If I just pass the number 21, it will be stored as an integer. So even though we're not storing any meaningful information after the decimal, if we've included a decimal in our pass to Python, Python will automatically store that number as a float and not an integer. So that's what's happening here on this line. Moving on. We see that Python auto-determines variable data types for us in many cases. Python is a programming language in which variables are dynamically typed, meaning we do not need to declare the specific type of the variable when we initialize it, right? That is the precedence of the conversation we just had between 21.0 and 21. Python determined what data types those variables were stored as. Because of this feature of Python, executing x equals 21 will automatically turn this variable into an integer. Likewise, executing x equals 21.0 will turn that variable into a float data type. All right, exercise 2, create and change some variables. Start by initializing a variable named 100 and assign it an integer value of 100 in the code cell below. Then print the type of the stored variable. Again, you can feel free to pause this if you would like to work on the exercise yourself. I'm going to type in 100, set it equal to 100, and then I'm going to print the type of 100. type. There we go. Actually, and while we're here, let me show you some nifty shorthand. If you hold down Control Shift and press the right arrow, the cursor will jump to the end of your current word, and then we can hold down Shift, open parentheses, and we'll automatically put both an open and close parentheses around the selected group of characters. All right, so quick, easy shorthand here. Now create another variable called largest computer in the galaxy and assign it the string value of deep thought in the code cell below. Then print the stored variable. Little Douglas Adams reference here. Largest computer in the galaxy, set it equal to deep thought. And now I'm just going to print the stored variable. Another useful shorthand here, notice that as I'm typing the variable name, it pops up in my tooltip. I can just press tab and that will automatically complete the variable name for me. And as I did that, I noticed a typo here. So I had a missing A in galaxy. Wait, galaxy? Yep, that's right, galaxy. So I was missing an A. There we go. The variable is passed to the output. There are many more variable types to explore in Python, both ones built into Python and ones created by open source libraries. The later sessions will cover more of these, or later rather, the later sessions will cover more of these types, such as lists and data frames in session 2. All right, math with Python, the moment I've been waiting for. I believe that this is where the intuitiveness of Python really comes into play. We often want to just do math whenever we get on the computer. And let's start by introducing some basic operators. Python allows users to perform mathematical operations fairly easily. As many tutorials will explain, you can use Python just like a calculator. The most basic operation, adding 1 plus 1, is as follows, using the plus sign for addition. So here I've just got 1 plus 1, the output is 2. Subtraction is done with the minus sign. 45 minus 32 is 13. Multiplication by the asterisk, so I have 12 times 90 equals 1080. You may combine as many arithmetic operators as you please. So here I've got about 5 different operations on a single line. And based on the data type, you can perform the same mathematical operations for variables. Suppose A equals 12 and B equals 24, and they're already defined. We can multiply the two variables together by simply referring to their names, A and B, and using Python's multiplication operator, that is the asterisk. So here on line 1, I defined A as 12, and then B as 24. And now if I want to multiply 12 times 24, I can use the variable names directly, A and B. A times B, or 12 times 24, is 288. Exercise 3, discover more operators on your own. Beyond the 3 arithmetic operators we have just demonstrated, there are many more in Python to discover. To start, try typing 14 divided by 4 in the empty code cell below. So I'll do this, 14 divided by 4. We get 3.5. Just by typing the computation and seeing the output on your own, you can quickly recognize that the / is a division operator. Now try 14% sign 4 in the empty code below. From the output, you can guess what the percent sign in Python accomplishes here. So I'll do this, 14% 4, and we return 2. So it turns out the percent sign is called the modulus operator in Python, and it returns the remainder after performing whole number division by the second number, the number coming after the modulus. So 14 mod 4 returns 2. Exercise 4, order of operations. Be aware that order of operations apply for programming, and Python is no exception. Python follows operator precedence, specifically PEMDAS. Any operations with parentheses take precedence, followed by exponents, and then multiplication, and then division, and then addition and subtraction. So let's try running the following code, 4 times 3 plus 4. So if we follow PEMDAS, the multiplication comes first. So 4 times 3 is 12. And then we add 4 to it to give us 16. Well, that was straightforward. Let's modify it to wrap parentheses around 3 plus 4. When you execute the code cell below, what output do you receive now? So because we put parentheses around 3 and 4, the 3 plus 4 comes first to give 7. And then we multiply 7 times 4 to get 28. All right. Throughout the notebooks in our Python Foundations course, you'll notice these headers called enrichment. Enrichment is here for you to peruse on your own if you would like. For the sake of brevity, I don't include them in the recordings, so we will move past this enrichment topic. But again, you can read through and explore on your own. All right. Code comments with the pound sign. Comments are notes in your code and can serve many purposes, such as describing the functionality of some code, to set a reminder to fix an existing issue, or to clarify details of some code for yourself, which happens quite frequently, or for other people. You can create a comment by using the pound sign. And when the Python interpreter sees this syntax, it doesn't run that code and recognizes it as a comment instead. For example, for a mathematical operation, let's add a comment at the end of the line to describe what this operation performs. So here I've got 2 plus 5, and then my comment, which comes after the pound sign, will say, adds 2 to 5, so we get 7. In this case, the pound sign adds 2, 5 to get 7 is part of the previous line of code was a comment appended to the end of the Python code, right? So it came after 2 plus 5 on the same line. By adding that pound character, Python knows everything after the character is a comment. All right, but in contrast, you can also write comments on their own lines. So here I've got the comment coming before the actual code that it describes. You may use this syntax for code that you may not want to execute, but still save for future reference or revision. To do this, you can simply add a pound sign at the very beginning of the line you wish to comment. In the following example, I've turned the first line of the code in the cell into a comment so that it won't run. So here's my comment. I commented out this line of code so you won't see the statement printed. And then I have the following line, which is actually a piece of code to run. And a quick note here, you can toggle between comments using Control /. So here I'm just tapping the / while I hold Control to toggle on and off this line as a comment. Super nifty shorthand to be aware of. Exercise 5, add a comment to a line of code. Let's write a comment that explains the following line of code, 25 mod 7. So I'll do this in the line before. Returns the modulus of 25 with 7, which is 4. Okay, 25 mod 7 is 4. Okay. Comments in your code are optional, but are recommended to help better inform readers of your code. Building a habit of writing comments may even help you understand and better explain your own code as well. This is especially true when you go to revisit code that you might have looked at for the past few months. Moving on, where can you run Python? Because of its flexibility as a programming language, Python can be utilized in many different ways. Here are just a few. Line by line in a Python interpreter and a command line terminal window. For Windows, the format I recommend for this is Windows Subsystem for Linux, or WSL2. Okay, and you can visit any of the Microsoft pages will have instructions on how to set up WSL2. For Mac OS, you already have the terminal available. And actually, this is a huge benefit for Mac users out there is Mac runs on what is essentially a Linux kernel. And so just by default, you have access to a terminal that can allow you to install Python. You can run Python as a script that you execute from the command line. You can create a full graphical user interface built on Python that runs on your desktop computer. You can execute Python directly from an IDE. So VS Code is a great example of an IDE that will just run Python for you. You can use a built-in Python interpreter, such as Pythonista. You can run it in an interactive notebook like we're doing now. If you're running this as a local Jupyter Notebook or Jupyter Hub or Jupyter Lab, you can also run it as a notebook in the cloud, which is what I'm doing in this video, is running it through Google Colab. You don't need to understand every example that was just listed. Instead, the point is for us to recognize how ubiquitous Python has become, okay? We're able to focus on the last 2 items on this list in the very next section. There's much more to learn with Python. So far, we've only introduced a small fraction of what's possible with this language, and more generally speaking, with coding. All right. So the next part of this notebook, this latter half, we're going to focus on just talking about and giving a brief overview of executing Python and exploring runtime environments. That is, the environments with which Python is running on our system or a cloud system. All right, using interactive notebooks. After just having discussed the many ways you can deploy and develop Python, we'll focus on the one way that will be used for our sessions this week, or however, with whatever cadence you're progressing in this course. That is interactive Python notebooks. Such notebooks, like the one we're looking at right now, are self-contained collections of interactive cells that can be modified and presented like a scientific notebook. By allowing us to combine code with formatable text, images, and interactive data visualizations, this gives us a great way to share and collaborate with others on our work. So, when I was a graduate student in chemical engineering at the University of Washington, uh, I, along with many of my research collaborators, used Python notebooks to share our analyses, right? It's the intermixing and the intermingling of code with text that allows it to be such a great tool for sharing ideas and analyses. We'll next explore the proper interactive Python notebook type that you'll get familiar with during these series, that is Jupyter Notebooks. Jupyter Notebooks is based on IPython, or otherwise known as interactive Python. In fact, Jupyter Notebooks were formerly known as IPython notebooks. Discussing the underlying IPython kernel, which powers these notebooks, is beyond the scope of this session. However, it's important to at least recognize where the .ipynb file extension comes from, right? So the file extension, the suffix of all of these notebooks is ipynb. And you'll see that in the GitHub repo specifically, as well as in the course titles if you've opened them in Colab. With Jupyter Notebooks, we can utilize the Python language right in a self-contained environment of code, such as initializing and managing variables. So here I've got var1 set to A, var2 set to B, var3 set to a data structure called a list that contains A, B, and C stored as strings. Right, so in these next subsequent cells, I'm just going to run through an overview of the utility of the Jupyter environment, and we'll get into the details of what's actually within these cells in later sessions. To continue, we can also write functions that can be used later on in a notebook. So here I've got a function, and I've got this keyword def to indicate that I'm going to define a new function. I've got the function name, I've got some parameters that are passed to it, and then I've got a computation that is run within the function and returned to the caller of the function. Now that I've defined the function, I can call it, right, by just typing in the name and passing along the requisite variables. Visualizations, such as scatter plots, heat maps, and charts, can also be generated directly inside of a Jupyter Notebook as a cell output and can be saved as a separate image file. This also makes notebooks useful to generate both visual representations of data and interactive reports on that same data. We'll be covering visualizations later on in this series of sessions. All right, just to demonstrate, I'm going to import some helper functions from other libraries. So these are called import statements here in this cell, and we'll get into those in greater depth. I then call a function that takes in some parameters, and I'm going to store the output of that function into a new variable space. Those outputs will then be fed into another function that creates a scatter plot. I'm going to tweak the output of that scatter plot, give it a title, and then show it at the output of the cell. All right, and so here's my simple example visualization right here in the Jupyter Notebook. We certainly recognize that much of the code you have just seen may be unfamiliar to you, but these are all simply reviews of what we'll be covering later on in this course. Here are some examples of how Jupyter Notebooks can be utilized. Reports on data analyses, to visualize data, and even to create interactive dashboards. All right, moving on, code cells versus markdown cells. There are two main types of generated cells in Jupyter Notebooks, code cells and markdown cells. You've seen both at this point. Right now, you're looking at a markdown cell that's been created already by a different user, happens to be me. Think of a cell as just a single entity of your larger work inside of a notebook. Let's start with taking a look at code cells. For writing and executing Python in a notebook, we use code cells. It may sound almost too self-explanatory, and you've already tried out code cells and exercises from 1.1 and others. To add a new code cell, you can either go to the Insert menu and select Code Cell. So I'm going to go up here, go to Insert, Code Cell. There it is. And here's a little screenshot of that. Or by hovering your mouse over to the bottom of a cell. All right, so I've hovered my mouse, and now I'm clicking this button, Code. Nice, so we can do it either way. And lastly, I mentioned this up at the top, we can simply hit Escape +A to enter a code block above the current selected cell, or escape and B to enter a code cell below. So here I'm going to hit escape and then A, escape again and then B, right? So we can do above or below. And then one last note, we can delete by doing Control MD, right? So we select the cell, Control MD. Exercise 6, edit a code cell. So far in this session, you've been creating entirely new code cells to write and execute a few exercises. Now, let's edit an existing cell of Python code. Below, we had our first exercise that printed hello world as the output. However, the code below, print hello world, causes an error and does not output hello world as we initially expected. What do we need at the very end of the line in order to print the statement to run successfully? Note, I also want you to uncomment the following cell block. How do we do that? Remember that we can do this by hitting Control /. Now it is uncommented. If I want to run the cell, I do Control Enter. Notice this, we get an error message. And the type of error is a syntax error. Unexpected EOF while parsing. We will cover in this course how to interpret error messages at a later time. This is a hugely important skill for the beginning developer. I cannot stress that enough, and that is why we have designated time to discussing interpreting error messages. For now, I'll interpret this for us. This EOF means end of function, right? So when we call a function, we're going to cover functions in a later notebook, but when we call a function, we need both an open and a closed parentheses, right? So even if we didn't know what EOF stand for, or parsing for that matter, or even syntax, the stack message, this error message, has another useful data point for us, and that is this caret sign on the error message. That caret is directly pointing to where the syntax error has occurred. So you understand that it is really, really important to feel comfortable reading error messages because they will make our lives so much easier. You also now can recognize the importance of creating error handling when you build your own software. All right, so I'm going to take this hint and add a closed parentheses to where the caret is pointing. And now our function runs beautifully. Code cells exemplify one possible benefit of running your code in a notebook rather than in a single Python script. You can create separate code cells and execute each portion of your code separately and as needed. That also means being able to troubleshoot certain lines of code without having to rerun your entire work every time. So just as we did in this example, you can focus on certain aspects of your analysis or your program and run those cells for that analysis or section of your program and debug them in this notebook environment, right? So you don't have to run an entire script every time you're wanting to iterate over different versions of a particular line of code, right? So just one other thing to keep in mind when we work in notebooks. So that's it for code cells. Now let's talk about markdown or text cells. As the name suggests, a text cell is meant for information and instructions rather than executing code for assigning variables, importing data sets, or generating plots. One benefit of adding text cells is to help explain code or functionality to viewers of a notebook. You can add a text cell either by going to the Insert menu and selecting Text Cell, right? So I'm going to go to Insert, Text Cell, there it goes. Or by hovering your mouse over the bottom of a cell and hitting Text, right? So here I've hovered to the bottom, hit Text. You may edit an existing text cell by just double-clicking on one and editing the information there. You can also have as many text cells as you want, cells that comprise technically any word length. Depending on what purpose it needs to serve, such cells may be a description of a data pipeline or a list of external leaks, etc. Now, whatever you want. Okay. All right, I can just double-click here to give an example. And you'll see that on the left is the raw alphanumeric characters that you've typed, and on the right is the rendered markdown, right? So markdown is a markup language. You can contrast this with HTML, which is a publication language. Markdown is meant to be easy for somebody to write in, but has a sort of rudimentary dress up that is done to the markdown code so that it looks decent, all right? So it's called a markup language. Exercise 7, write a very UW text cell. Create a simple text cell that reads the official tagline of UW. So we can open this link. I myself think it's called Be Boundless. Be Boundless. Yes, so that's the tagline. All right, so let's go ahead and click into this text cell. And we'll just write Be Boundless. Right, and so there it is on the output of the text cell. Markdown for text cells. Text cells support Markdown syntax, which is a way to render and format plain text. In addition to giving us more control to structure this text beyond just visually, Markdown is optional and enables you to transform and annotate text within a web page or here in a Jupyter Notebook. For text cells, using Markdown improves readability as a set of formatting conventions that's easy to learn and write. Right? So Markdown is supposed to be easy to write. Markdown is a superset of HTML. Discussing HTML is beyond the scope of this session, but there are links to read more about this later in the notebook. Alrighty then. Exercise 8, discover some Markdown syntax. Create a new text cell below with the UW official tagline like before, only this time play around with pound signs at the beginning of the line, double asterisk around text, single asterisk around text, and then right caret. All right, so let's just continue this. So let's do Be Boundless. So I'm just gonna keep using Be Boundless as my thing that my string that I'll use. And then let's try double, let's try single, let's try caret. Nice, so we see that the pound signs indicate headers, right? So a single is a header 1, 2, header 2, and so forth. Double asterisk create boldness, single asterisk create italicized strings, and then the right caret creates what's called a quote block. Later in the lab for this session, you'll learn more formatting syntax with Markdown. We also recommend trying out Markdown on a blank new Jupyter Notebook for you to experiment with all the different formatting this markup language has to offer. There's much more to discover with Markdown, and the references section of this notebook gives you a list of resources to learn more. Exercise 9, always double check the type of cell you're running. It can be easy to mistakenly write something in a code cell when you actually wanted a text cell instead. For example, what happens when you hit the play button on this particular cell, right? So if I were to select all, uncomment, this the Python environment thinks this is a code cell, when in fact I meant for it to be a Markdown cell. So a simple way to change this is to hover again, open up a text cell, and just copy and paste everything in that text cell. All right. Other details on Jupyter Notebooks. Jupyter Notebooks, that is .ipynb files, don't just work with web browsers. There are IDEs such as VS Code that have extensions which allow you to create and edit these IP notebook files right on the editor. So I personally like to use VS Code to edit my notebooks. Python isn't the only language supported by Jupyter, as you can also run notebooks with R and Julia as well by adding specific computing engines for them. Notebooks, both in Jupyter and Google Colab, can integrate directly with GitHub repositories. So, anytime you create a Jupyter Notebook and store it on a GitHub repository, it's kind of awesome. Google Colab will allow you to open that notebook in their cloud environment. So in fact, that is, I've leveraged that fact with this course. So really great integration between Google and GitHub. So what does this have to do with Google Colab? Google Colab is based on Jupyter Notebook. Both the notebook platform and the development machine are hosted on the cloud. No need to install Python or external libraries locally on your computer. We'll be using Google Colab for this course. That includes all exercises and projects. So when you see me run these videos, I will be running them through Google Colab. I will stress that if you are serious about developing Python, you will want to set up a local environment. As I mentioned before, I highly recommend, if you're on a Windows system, WSL2. Once you've set up WSL2, it's a simple matter of installing Python. And then when I run notebooks, I already mentioned VS Code. Another method that I really enjoy is Jupyter Lab. So again, there are many instructions online to set that up locally on your machine. Google Colab comes with pre-configured images with Python libraries pre-installed. Some of the most popular scientific libraries include NumPy, SciPy, Pandas, Scikit-learn, TensorFlow, Matplotlib. We'll cover some of these in Python Foundations. If you're interested in learning more, we cover all of them in both Python Foundations, Data Science Foundations, and General Applications of Neural Networks. All of those can be found on my as well as the UW-GIX website. To view the full list of installed packages, run the following command. So I have an exclamation point here followed by pip freeze. We won't have time to get into all the utility of the exclamation point that I'm using here, but just know that this exclamation point escapes the Python environment and brings us to a terminal or a bash window, and then we can execute bash commands. So this pip command is short for PyPy, and this freeze is a command within pip, and it just tells us what modules or libraries rather are installed in our local Python environment. You can see that Google Colab comes with a huge amount of pre-installed libraries for us to use. Very nice, very nice. Thanks, Google. Okay, and just to reiterate, the exclamation point syntax seen at the beginning of pip freeze is for running terminal or shell commands directly within Jupyter Notebooks. Terminal commands are outside the scope of this session. And that's it for today. Resources and further reading. This section serves as a reference for many other resources to learn about what was introduced here. So here's a resource on Python versus Excel, along with other resources on Python, a table to reference other arithmetic operators in Python, resources on the Jupyter Notebook, and then resources on Markdown. As you're working through the course, I invite you to visit this schedule page. So today we have just finished session 1, Python and Jupyter. If there is an associated lab with a session, it will be listed under that same row in the schedule table. As you can tell from the schedule, I like to delineate this down into 8 sessions. So there's 8 different sessions for all of the content on this website. And there is a lab for this session. So if you would like to complete the lab, navigate to Labs here. The one associated with this session is called Practice with Python and Jupyter Notebooks. You can then hit Open in Colab. You will then be able to run this and complete the exercises. If you get stuck or just want to check your work, again, visit the root directory of the website and then visit this link, access the solutions if you get stuck. This will bring you to the Python Foundations GitHub repository under the subdirectory where all of the solutions are stored. And the solution that we're interested in right now is this one, L1, Python, and Jupyter. So L1 is short for Lab 1. And here you can see my solutions to this lab assignment. Thanks for visiting and good luck.